Spinosaurus. Wow, what an unusual dinosaur with an unusual history. It doesn't matter whether you're coming at this guy from a perspective of science or a perspective of pop culture. It's just got this mystique that really cannot be beat. And in the past decade or so, we have learned more about Spinosaurus, or theorized more about Spinosaurus than at almost any other time period. So it's a really exciting and maybe frustrating time to be a Spinosaurus fan, depending on what you think of it. Here we are. So Spinosaurus is one of the most popular dinosaurs out there because of that mystique. It's got a really unique sort of a look to it, and that leads to museum exhibits sometimes like this. Gives us kind of a false impression that we know what Spinosaurus is like. This particular skeleton was created before 2014, which means that it was using kind of a smorgasbord of a skeleton that was blown up in World War II, and we only had pictures of it, a bunch of pieces that we don't know whether it really came from Spinosaurus or not, scattered across North Africa, and a number of related animals. So this is almost entirely a big guess. It's not too far off in some ways, but it does give you the idea that we found like this whole skeleton of Spinosaurus and we know what it looks like. The opposite is true. It is a very mysterious and poorly known dinosaur. But it's so weird, we love to study it, and so we end up talking a lot about it, and sometimes that talk is not founded well. Spinosaurus was discovered in the early 1900s by this guy. His name is Ernst von Stromer, and he was a German who headed down to Egypt, actually, and found a number of dinosaurs new to science. Among them would be Carcharodontosaurus. But, it was a real Indiana Jones sort of a thing, except it was dealing with fossils and not archaeology, and didn't have anything to do with the Nazis. They hadn't been invented yet. Okay? So he comes back to Germany with a bunch of different fossils. And fortunately, maybe even because he's German, he took very copious and precise notes. So we had some really good illustrations of the bones that he found. But for a while, we didn't think we had any photographs. More on that later. These are some of the bones that he found, and they're not shown to scale at all right now. This down here would be part of the lower jaw. Got several teeth. There's part of the lower jaw again, so same thing, just opposite side. But the most intriguing thing that he found here were backbones that had these incredibly long spinous processes for which the animal was named. And that was the basis for what he interpreted as a large sail. Other scientists have interpreted it as a large hump. You see the same sort of thing, for example, in bison. Bison don't have sails on their backs, but they do have these big kind of humpy sort of shoulders. Turns out we did have some photographs that managed to survive, but we didn't rediscover them until about 2015. This is one of them, and so you can see, it's kind of hard to see in the way that it's projected now, but this is part of that lower jaw. You got those teeth, and then a couple of neck bones, and here's that backbone. Check out that sort of odd M shape to the top. That'll figure in later. But this is what we had, and this is how they displayed it in the museum before it got blown up by an Allied bomb. Totally destroyed. And so for about 70 years, we had no real Spinosaurus bones, nothing that we could confidently assign to Spinosaurus. And the holotype skeleton, the skeleton that we're supposed to compare everything with, was gone. Stromer interpreted it this way. You can see it's not that M-shaped sort of a sail. We've got kind of this D shape to the sail. But he figured it did have a rather long torso. The rest of it he kind of restored as a dinosaur that looked like a fairly typical big meat-eating dinosaur, specifically the megalosaur family, and believe it or not, that association has kind of borne out. We do think the Spinosaurs might be descended from the megalosaurs or related to them in some other way. Now, because of that long torso, and he restored it with fairly short legs for no reason, like you can see the dark parts here are the bones that he found, but the rest of this is just spitballing, trying to get some kind of a shape of this thing. This is his guest. He's got it kind of in the kangaroo pose, not just because dinosaurs were kind of believed to be tail draggers, but look at the tail back here. It's not really dragging its tail. He's got it in an upright pose in part because of that long torso that would seem to make it want to lean forward and maybe even walk on all fours. The thing is that there's no meat-eating dinosaur we know of that would be walking on all fours. That just isn't the pattern. He didn't just find the Spinosaurus holotype, he also found what he labeled as Spinosaurus B. It looked an awful lot like Spinosaurus bits, but he wasn't 100% convinced that all this stuff also belonged to Spinosaurus. And so he gave it kind of this tentative name instead of describing it as a new species. Okay? There might be some indication that Stromer was very wise to do that. Several fossils since then have hinted that there might have been two large Spinosaurs kicking around North Africa at about the same time. And one paper suggests that Spinosaurus might be the smaller of the two. Stromer's idea influenced artistic representations of Spinosaurus for many, many years to come. Generally, it had these sorts of proportions, but it was almost entirely a guess except for that fin. So when you look at Spinosaurus art, it's going to have a very mixed sort of a quality, and no two Spinosaurs would look the same. We even ended up with this odd trope of Spinosaurs going about on all fours. Now, that might be due in part to its resemblance to an animal called Dimetrodon. There are actually a bunch of different kinds of animals that had sails on their backs. Dimetrodon's only one of them. There was another animal living at the time called a Dilophosaurus. It also had a fin on its back. There was an amphibian living at the time that had a fin on its back. There was a protodinosaur living tens of millions of years afterwards, but it had a fin on its back. So we get a lot of fin back sort of stuff, and a lot of it's walking around on all fours, so a lot of artists were tempted to put it on all fours. The thing is that theropod arms can't bend that way. This is not science. This is Spinosaurus headed into pop culture and the stuff of science fiction. In the mid-'80s, we kind of hit a breakthrough in studying Spinosaurs, at least as a family, and that led to finally some traction in figuring out how Spinosaurus worked. It was this animal, Baryonyx, which you can see here at the park. Baryonyx is the most complete theropod to have been found in England. It was such a good skeleton that we got a really good look at what it looked like. So, as a result of this discovery, you end up with kind of a sea change in artistic representations of what Spinosaurus would look like. The whole idea of artistic tropes kind of backwashed into Baryonyx a bit, and a lot of early pictures of Baryonyx you'll see will be going down on all fours. Our sculpture doesn't do that, but you'll see that from time to time. And again, its arms could not bend that way to make that happen. So here's part of that sea change. This one's a little bit more on the fanciful side, more on the pulp culture, and I don't think anybody's trying to claim that this is strictly scientifically accurate Spinosaurus, you know, the scales and everything. But it's kind of a fun, dragony sort of looking dinosaur, even without all the decoration. But you can see with this one, it does have kind of a typical sort of theropod body, but now it's got these huge claws on its hands that it didn't have in earlier artistic representations. It's got the crocodile-looking sort of snout there. In the late 90s, we started exploring North Africa for dinosaur fossils again, and we started turning up stuff that could be Spinosaurus. It's just isolated and kind of junked up. And because it didn't cross any parts of Stromer's original skeleton, at least anything that he left in the notes, it was really hard for us to say definitively this is Spinosaurus. So you get some referrals where people are saying we think it's Spinosaurus, and they could be right. There's just no way for us to tell at the moment. The thing about fossils like this, you might not be able to assign them to any particular species, but you can still do certain tests on them. And so this allowed us an opportunity to say, well, we're going to test this animal that could be Spinosaurus, or maybe something that's just like Spinosaurus, but either way, it's going to give us more of an idea of what Spinosaurus would be like. So, 2014 rolls around. A few years before that, a scientist by the name of Ibrahim, he was doing some studies in Morocco, which is a very fossil-rich sort of a country, and happened upon a claw somewhere in a marketplace. And he recognized that as being similar to material that Stromer had uncovered, so he did a little bit of detective work, and it led him to a site that had a skeleton that was even a little bit more complete than the one that Stromer had found. Now, because we had a halfway decent skeleton of Spinosaurus again, we did something that's technically known as a neotype. This holotype sort of a concept, like I said, we have to have something that we can compare new fossils against to see if it's a member of the same taxon. Since that had been destroyed in World War II, but we had a new skeleton now that compared favorably with Stromer's notes, that gave us a chance to give it a neotype. Now that we treat like it's the holotype. It's not the holotype, but since the holotype is gone, we go with the neotype. Neo just means new. That neotype skeleton introduced some interesting ideas. First off, we found that those back legs actually were really short, a lot shorter proportionally than we see in most theropods. The sail they restored back to kind of that M sort of a shape. But then there are a lot of other things that kind of, in order to get a complete picture, they ended up adding a whole bunch of other bits and pieces, okay, from all over North Africa. And they did this based on an assumption that all that big Spinosaurus material all belonged to one species. Stromer was not quite so confident. What you've got is this kind of rainbow sort of a skeleton here. The different colors represent different sources. So this red stuff, and technically there's some orange in there representing the holotype. They're so close you can't really tell them apart, even if you're not looking at it on a projected screen. But that reddish stuff, that stuff that we can confirm, yeah, that's Spinosaurus. This is the same taxon as what belonged to whatever Stromer named. On the opposite end of that spectrum is stuff that we just had to make up, and that would be the blue stuff. We don't know that that's there, but that's based on patterns of how animals are put together, and that's our guess, okay? Like the white parts of Stromer's skeleton. The green parts here, bits of the skull, bits of the arm, those are based on related Spinosaurs, stuff like Baryonyx. There's a fun Spinosaur called Irritator. We've got stuff from the skull for that. And so that's where that stuff comes from. And then the yellow parts are referrals, stuff that doesn't appear to belong to any other kind of Spinosaur. It's a real fossil, and we just kind of lump it in with the rest of Spinosaurus. So you got these front arms, and that's kind of a big deal. The snout there, you saw that snout earlier, so that's been referred to Spinosaurus. The thing is that that's based on that assumption that everything is supposed to belong to Spinosaurus, and papers before and since have said, no, we could have two animals in the same size bracket, and that leads to this probably being what we call a chimera. It's kind of like a Frankenstein's monster of a couple of different species kind of hashed together in order to get a more complete picture. This was a huge step forward, and it's a better model than pretty much anything that had come before, but it's got a number of problems as a result. So this is not what Spinosaurus looked like. This is what we thought Spinosaurus could look like. And there's one other feature of this slide here. See that red dot? That is the center of mass for this model. And this is one reason why the scientists who proposed this 2014 model have depicted it on all fours. If that's where the center of mass goes, and its tail is so long that it can't raise itself up like Stromer had it, then it had to have gone on all fours. The trouble with that is that this referred Spinosaurus material, well, we don't know that it belongs to Spinosaurus. We don't have any forelimb material to test it and see if it really could bear that kind of weight. There are some quirks to meat-eating dinosaurs' forelimbs. They can't bend like ours can. That's one reason why they have it doing this kind of knuckle walk. Now the funny thing is that they said that it was extremely awkward on land and specialized for living in the water, but they said that it was a species all across North Africa. Well, if that's the case, how is it remaining a species? They're either predicting that there was a large body of water across North Africa that would allow these animals to swim and keep the gene pool all one species, because they certainly weren't walking. But we don't have any evidence, and they never mentioned anything about the geography or even, say, like mountains that would cause a large river system like that. Think of the Amazon River basin. That river can get so big because it's coming from the Andes. So clearly there was a lot more for us to learn. Now this is a much better schematic from a later study by some of the same authors. And this shows you, in a schematic way, the locality where it was found. This red wedge is where that neotype skeleton was discovered. The green stuff had bits and pieces of the tail, which they didn't know that they had because it had been scattered. And that's a very different looking tail from what was in the 2014 model, isn't it? Very deep, kind of eel-like. And so these authors took a look at that and said, whoa, yeah, that is excellent evidence supporting our hypothesis. Another nifty thing about this, you can see the tail is actually the best preserved part of this. The legs maybe the next best preserved, but then like even bits of the sail, skull, these are all kind of broken bits and pieces. The nice thing about these bits and pieces is that they are still preserved in 3 dimensions. So even though they're broken up quite a bit, they're not bent. Sometimes rock will cause bones to deform. They don't look like they're broken, but they are out of shape. And that didn't seem to have happened with these, so we got pretty lucky there. But you can see just what kind of material we're dealing with from North Africa. And this is pretty typical of North African, especially the meat-eating dinosaurs. You just really don't get a lot. So this is really good for what we've got. And this is kind of a schematic and a restoration of what we've got there. So they did kind of an interesting experiment to see if this tail could be used for swimming. And what they did is they took a piece of plastic and cut it out in kind of the 2-dimensional shape of the tail. Then they did the same thing for Coelophysis, which you can see a Coelophysis skeleton right down there, long, thin, whippy tail. Allosaurus and crocodile, and I can't remember what kind of a newt, but they had like some kind of a frilled newt with a really deep tail like this. Okay? And then they connected it to a robot that would put it back and forth in water, and then they tested what kind of thrust they were getting off of it. And they said that their results said that this tail was 8 times more powerful and twice as efficient as that coelophysis tail. Yay, right? That coelophysis tail ain't for swimming. So 8 times ain't for swimming does not necessarily mean super, super powerful. Compared to the crocodile and the salamander both, Spinosaurus' performance was about midway between Allosaurus and those guys. So maybe not such a great tail for it. They did note that this tail was flexible. Normally, dinosaurs have these kind of spurs coming off of the bone that they're struts that kind of help to stiffen the tail so that it won't be flopping all over the place. Normally, with meat-eating dinosaurs, you'll get it more flexible at the base of the tail, and it gets stiffer as you go along. With Spinosaurus, it's different. It's flexible, but still stiffer at the base, and it gets less stiff towards the end. Or rather, those struts get smaller and smaller. There's kind of a problem with that, though. They noted that theropod tails have that stiffening towards the back, and yet they treated it as if they were all flexible, the same kind of flexibility as crocodiles and this newt. That's a problem with the experiment. Another problem is that they forgot to think about this stuff up here. Look at the base. Can you see how at the base these spines coming off the back go almost straight up? Okay, that's going to be nice and flexible. Not so bad. Go about midway down the tail, and you've got these spines kind of angling inwards. This spine, according to how they restored it, crosses 2 other backbones. You get further down, here's 1, 2, 3 for that spine. This one goes 1, 2, 3, 4. That tail wasn't getting more flexible the farther down it went. It was getting stiffer because of these things up here. It was still acting like struts to stiffen the tail, and that might be why these ones down here were getting smaller and smaller. Didn't need to be stiffened because it was getting stiffened this way. Still mysterious. I'm not going to draw too many conclusions from that, but that's very interesting and kind of a note of how detailed you have to get in your examinations of Spinosaurus, because it's just that weird. We've got a new model as of about a week ago. Now, this paper is so new, it hasn't been officially published yet. It's just a preprint, and it's still going through review by other scientists. Okay? So this is also something that you need to take with a grain of salt. But the lead author to this paper was one of the contributing authors to the original 2014. It kind of makes it look like he took a look at that tail and said, oh, I might be wrong, whereas other scientists took a look at that tail and said, oh, well, we might be right. So the plus sign that you see here, that's the center of mass for this model, and if this model is closer to what Spinosaurus would have looked like, it's right over those legs. There's no reason for it to be quadrupedal. And that solves a lot of problems because, again, what we've referred of these arms, we don't know what the arms look like, but we have no reason to think that they were specialized for walking on all fours. And an animal this big would have to have some kind of specialization like that. The torso is somewhat shorter. You can see here with the color coding, it's a little bit better. The red stuff is from that original skeleton that got blown up. The blue stuff is from the neotype, and then that yellow stuff is the referred stuff, and white is just, we don't know. That shoulder blade, it was yellow on that 2014 skeleton. Now, I don't know what happened to that, and I don't have enough information from these guys to figure that out. So still lots and lots to learn about Spinosaurus. But if we look at this model, they found that this animal's lung capacity was too great for it to dive at all. It's not swimming underwater like you would see in many, many pictures. The tail, they mentioned that stiffening aspect to it, and so it might not have been very efficient for getting through the water as you might think. but the center of buoyancy is fairly close to the center of mass, and that made it extremely tippy in the water. Okay? It would be great if it was in the water, walking along, the water level got about that high, then it would start to float. So that means it could go into fairly deep water, maybe like 8 to 10 feet, just kind of spitballing there. And that center of buoyancy would allow it to have its head down in the water most of the time. But it does kick that tail up into the air, so it couldn't be very helpful as a propellant that way. The spine, this big fin that's been there the whole time, it's the most famous part of this animal. Have you ever looked at a sailboat, something that like people might get for sport? It's got a small hull, really tall mast, and underneath it's got this deep sort of a keel, right? Where's the keel on this guy? Tall spines, not much of a keel. This animal gets in the water and it goes right on its side because there's nothing to stop that from tipping the whole thing over. Now I've heard arguments that, again, maybe this was acting as some kind of a keel to stabilize it, but it's not deep that way, it's deep up this way. It's not going to be terribly helpful for that unless it's able to get in the water, and this animal's having problems getting around in the water before that tail ever comes into play. So it's not looking very good for a swimming sort of an idea. This paper went into a lot of other really interesting ways of going about it. It looked at patterns of evolution among animals that went from land back into the water. From the land into the water, if your family does. You get specialized for the water, so like a whale, right? It almost always starts small, and you don't get big until you're fully living in the water all the time. Okay? When it deals with animals that are just kind of going into the water sometimes, like, say, ducks or swans, well, it's kind of the opposite. You don't have to start small. You can get big and then get into the water and you're fine. That kind of puts a big burden on the argument that Spinosaurus was becoming specialized, unusually specialized for the water, because Spinosaurs were continually getting bigger and bigger, but they were getting bigger and bigger as they were going into the water. That's the opposite of the evolutionary pattern that we're seeing. So that's an extraordinary thing. Maybe it happened that way, but in order to make that argument, we need extraordinary evidence to overcome all the stuff that we're seeing elsewhere. Definitely went into the water and lived around the water. Those teeth are designed for grabbing onto fish. The snout, even if we're just looking at the bottom part, that snout is designed for catching fish. This is the skull that we have. You can see it's kind of a different model from what you'd see in the 2014 model, and I kind of like that because it makes our Spinosaurus sculpture less authoritative. The sculpture shouldn't be authoritative. It's a work of art. It's not the science. This isn't necessarily the science either, but this is, again, kind of spliced together from a bunch of stuff across North Africa that we think goes to Spinosaurus. This could be what Spinosaurus' skull looks like, but it could also be another chimera. Here's another rendition of it that kind of looks like the skull that we've got there. But you do see, you got that wiggly sort of line to it. That's great for catching fish. Other studies have ground up bones that could belong to Baryonyx and Spinosaurus, and found that the isotopes within those bones match the isotopes that you find in alligators and freshwater turtles. So yeah, these animals definitely were getting a lot of their food from the water. They were living around water, but they might not have been specialized to live almost exclusively in the water. They might have just been comfortable in the water. So because of that mystique, Spinosaurus, of course, has become popular in pop culture, and you will find many, many variations of Spinosaurus, possibly even more now because of that whole scientific tangle and us trying to figure out how Spinosaurus really was. Well, we're getting a whole lot of models that are spinning off into some interesting art. The Spinosaurus from Jurassic Park 3 did predate a lot of that kerfluffle, and so it's going to look kind of like a typical meat-eating dinosaur, but with longer arms and that more crocodile-like snout. But the filmmakers definitely chose this guy to kind of up the game past T-Rex. They figured that people were getting tired of T-Rex. Are you guys tired of T-Rex? Nah, nobody really is, but that's what they were afraid of. So they brought in Spinosaurus because it looked so different, it was impossible to mistake as being different. They portrayed it as being much bigger than Tyrannosaurus Rex, and you can see that here. But as you can see from our explorations of the science, it would, the scale is definitely impressive, and it might look bigger than Tyrannosaurus Rex, but in terms of weight, it would have been in the same ballpark, if not smaller. And of course, science fiction, it's such an exotic animal with that kind of reality to it that it's tempting not to just kind of go crazy with it. This is, of course, from Michael Bay's Transformers movies. This is Scorn the Dinobot, and, well, because it's an alien robot, they can get away with all this scientific inaccuracies and stuff. It's got like 3 fins, too. Basically, with Spinosaurus, if you're a scientist, it can be a little bit frustrating because it's so tantalizing, but looking at it, especially from a pop culture end of it, it can be a lot of fun. So that's our presentation for this week. Next week, we're going to be talking about documentaries and how they're made. We've had a lot of dinosaur media come out recently. Jurassic World Dominion, a big one there. And we'll talk about, how do we figure out the fact and fiction behind that, and should you be taking all of this as scientific or with more of a grain of salt?